Hello everyone. So we are back with some another lead code questions, solving some DSA pattern, some DSA questions. So today we are going to solve some pattern based question which are generally being asked in interviews. So I've already opened a website where I've got a 14 pattern to ace any coding interview question. So we'll try and pick questions based on this uh, patterns, and we'll go to each pattern and we'll solve one questions for every pattern, and then we will try and pick any random question, and then we'll try to fit it into a pattern and then solve it. So there are a total of 14 patterns that are given over here. So let's try and let's see how many patterns can we solve today. If any pattern will be left, we'll be solving in the next stream. Okay, so this was the website which I found from this lead code 14 pattern to ace any coding interview question. So it's not very much clearly written over here. All the images are even not there. So there is a link, says this is the original post link. So I picked it from here, and now I'll be solving from here. Yeah, I know I'm a little late. I was taking breakfast today, so I got late, but we are fine now. We're good to go. Um, we even have common problems which are given on the based on the sliding window. Okay, so let's start with the first pattern, that is sliding window. Let's start my timer. So the first pattern that we will be doing is sliding window. Open my So this sliding window pattern says a sliding window pattern is used to perform a required operation on a specific window size of a given array or linked list, such as finding the longest subarray containing all ones. Sliding window starts from first element and keeps shifting right one element and adjust the length of the window according to the problem that you are solving. In some cases the window remains same constant, and in other cases the size grows or shrink. So if you don't know how the sliding window approach works, I have some intuition before, so I'll just give you a brief idea. Maybe um, what I needed to do is somehow find a window. There is given an array of some length, and now I have been given a pattern that I need to find a pattern something like this in the array. So suppose the pattern is saying that find all the ones, all the continuous ones. All the continuous one length, maximum length of continue all the continuous one. So if I say 1 0 1 1 1 0 0, if this is my array, what we can say, this window is a window which contain one only once. Okay, this window contain ones 3 times, and this window contains nothing. So what we will do, we'll use a sliding window. So in this case, what we can do is we use a sliding window. We'll start from I pointer and J pointer keeping at the same position, and then we will slide one by one. If we found is if we find something, we'll move forward. If we find one, we'll increase our window. If we find a zero, we'll shrink our window. So it will go something like this. So if I find a one, my window will increase. So from 0, I will remain as it is. I is my nothing but my left pointer. This is my left pointer. This is my right pointer. So if I find a 1, what we can say is that okay, this we can add it in our answer, and so what we'll do, we'll shift our right pointer to the next index over here. This is 0. We know that we don't have to include 0. We have to find all the continuous ones that is present over here. So what we'll do, we'll shift our left pointer to the point where right pointer points, or even a pointer plus to the right pointer. So I'll point it over here. My left pointer will fall over here. My right pointer will also fall over here. Yes, bro, I got snacks. Mhm. So now this is 1. What we'll do, we'll shift my right pointer again to the next index. This is also 1. We'll shift our right pointer again to the next index. This is also 1. We'll shift our right pointer again to the next index. Now this is 2. So what we'll do, before shrinking my window, we will we will be calculating our answer. So if I add index to this array 0 1 2 3 4 5 6, so 2 to 4, 2 is my left index and right is at 5 index. So what we'll do, we can directly subtract 5 minus 2, which will give me 3, which is nothing but this window. So 3 is my will be my one of the answer possible answer. I need to find the maximum of it. So I can see I have already found a answer which is 1. Now I found an answer which is 3. So whosoever will be bigger will be stored in our answer resultant. So 3 will be stored in my resultant for now, and then my left pointer will do what? Left pointer will directly jump to right plus 1 over here, and also my right pointer will jump to next. Now we found a 0. My my left pointer will move to right pointer plus 1, and my right pointer will be next, and we are out of bounds. So in this way we'll be using the sliding window approach. So it's very common or and very general uh, interview question, where every time we'll be getting these types of question where we have to use sliding window approach and solve the question. So if you'll have any doubt, let me know. I'll try and I'll explain it in a much better way. So it's given over here. Following are the way we can identify the given problem, uh, which might require a sliding window. So these are points which is very important. Let's see what it is saying. The problem input is a linear data structure such as linked list, array, or string. So if it is a linear data structure, then we can think of solving it using uh, a array. If it is an array, if it is a linked list, if it is a string, even a string, we can use this to solve. We can use sliding window to solve the problem. Might be one of the approach can be a sliding window. Now if the second point says you are asked to find the longest, or shortest substring, subarray, or a desired value. So it's always going to be a contiguous. So it's saying longest or shortest substring. Substring is always a contiguous part. Subarray is also a contiguous part. Or the desired value, whatever the desired value based on, it will also be in a contiguous way. So sliding window will only be applicable wherever it is very much contiguous. Okay, so this way we can use the sliding window approach. Now let's try to solve a question. Maybe I'll directly jump to medium, uh, and then we'll try and solve the hard one also. So let's pick this longest substring with k distinct characters. So longest tea. No, bro, I don't drink tea. Okay, this is not. Okay, let's try and solve this question. I mean, I didn't get the question which is over here. Longest substring with k distinct character. Too much light from background. Hmm. Okay, I'll do it after this, after the break, in the break. Okay, so let's solve this question. Hopefully we'll get a sliding window approach over here. Let's see what the question says. The question is given a string s and an integer k. We are given a string s and an integer k. What we need to do, we need to return the length of the longest substring. It's saying substring. The pattern here was also saying substring. You are asked to find the longest shortest substring, and the question is also saying to find the longest substring. So this will give me an intuition that okay, this problem might be one of the sliding window approach. I'm not saying that it will be 100% sliding window approach only, but I can I, I can think of a sliding window approach based on few keywords that are used in the question. So let's see what this question has. So we need to find the length of the longest substring of s such that the frequency of each character in the substring is greater than or equal to k. Such that the frequency of each character in the substring is greater than or equal to k. It is saying the frequency of each character should be greater than or even equals to k. Yes, bro, we cannot use your sliding balcony. Yeah, you use it by yourself. So saying I need to find the length of the maximum that is equals to k. So we have a substring a b b, k is 3, So in this case what we will do is we need to find a substring. So we can see in this will be my answer because k is the number of occurrence of a is 3 times, and the window is maximum it can go is the length of 3. So the length is 3 that we will be returning from here. Now here k is 2. We have been given a b c, and k is 2. So we need to find the, so we can see if we can see here we have a sliding window of length 1 2 3 4. We can see a is occurring twice, b is also occurring twice. Now c, we cannot add c. It's saying okay, it can be greater than or equal to k. So it can be greater than, so we can also extend this window from here to here also. So this is the 5 characters 5 in which b is occurring 3 times and a is occurring 2 times, and all b and a are greater than 2 or even equals to 2. So we can say that this is 5 length ABABB will be in our answer. So this way we can solve this question. Now we have to think of how to approach this question basically. Now we need to know how to move our sliding window, when to move our sliding window and when to not move our sliding window. So one thing that I am getting an intuition is, if I somehow get to know that how many A's and how many B's are in total present, then maybe we can think of uh, something. So let's take an example and see if it is possible to figure it out. Okay. Now, what my thinking is going, I need to know uh, at this position, if I'm at this position, how many B's are present beyond this, or how many C's are present beyond this, how many A's are present beyond this. I need to know for every index how many character values are present beyond this index. So at this index, I suppose 0 1 2 3 4 5. At this index, which is index number 3, I need to know the values of all the characters that is present. It's something like this, but we cannot afford to make these much of space. We cannot afford to take these much space from every, let's say, closest sliding gate balcony. So this way we can um, so we need to think of something where we can keep track of how we will approach. Uh, we need to know, is there any B present beyond this B. So what we can do is somehow we can keep a character. Let's take the frequency. We'll keep a frequency of A. We have a total frequency of 2 of A. The total frequency of B is 3. The total frequency of C is 1. Let's just add a few more B's over here just in order to understand it better. So what we have right now is we have a total of 2, 3, 5B, 2A and 1C. You can store all alphabets in hash map with the frequency. Yeah, correct. That's what we are thinking. We can store all the frequencies in a hash map, and then we can think of something. So I just need to know like if I'm at this position. So currently I have iterated 3 frequencies already. So we can store it in somewhere else, and we can create another hash map. Uh, where we'll track each and everything one by one. So what we'll do is first we have A. So K is 2. I need to find that whether I'm able to make A 2 times, whether it is present or not in the near future. So if A is present, we only encountered one A currently, but for completing K we need one more A. So is there any A present in the future of this array? So for that we can use a hash map. So if I have one A over here, so how many A do we need at least minimum? So which will give me 2 minus 1, that is 1 A is required for the uh, it should be there in our future, so that we can say that yeah, we can keep this A in our sliding window. So this is required. Now the same thing we can do is we need to check it with this A, which is which has all the frequency. So 2 minus 1 will give me a total of 1, which is present in future. So these are both same 1 1. So now we can say that we can consider this A in our sliding window. Now if we move our sliding window and we reach at C, now C's frequency will be over here as 1, and we if we check, we require 2 minus 1, that is one more of C in the coming future, because we have encountered only one C. And if we similarly check how many total C's are present, so only one C is present, and this these frequencies, if we subtract this by this, so 1 minus 1, in future we don't have any C present, so we can say that we cannot increase our sliding window from here. So this is the maximum sliding window that we can approach to. We cannot move to C, so we'll have to stop a sliding window till here, and then I'll move my sliding window from here to the next. So my pointer will go to left and right. Okay, so this is what I am thinking of doing. This way we can approach this question. Let's try and solve it and see whether I'm getting the correct answer or not. And also one more thing I'll have, uh, I have to remove if I'm reaching over here and we found out that we cannot move any further, so we'll iterate my left pointer from here till here and reduce all the frequencies of these from our main frequency box, because we don't we already have at positioned us at right and left. Or can we do it with only single hash map? But pattern will be lost in that way. No, I don't think pattern will be lost in that this way. We already have the pattern. Uh, if we can do something without using even the secondary map, we can directly do it with the primary map itself. That will be much more easier. We encountered A, we reduce the frequency by 1. Now we know that we still have 1A present in my future, but it might be possible if K is 3, if, if my K is 3, so only 1 is present in my future, but we need 2 more in the future, so we can't take this A, so we need to move our left pointer to the right one. Correct. So how we need to figure out mm, how many we have already encountered. For that we still have to keep okay. So for this we still have to keep a secondary map. We cannot do it with the primary map itself. So let's try it and use the secondary map also. So keep a unordered map of character with its frequency. This will be my frequency map, and also will have a secondary map which will be my count map. Maybe initially what I will do, I'll keep it in my frequency, this S of I plus plus. This will be my frequency map, correct? This will contain all the frequency which are present. I'll keep two pointers. That is my left pointer, which will be at 0, my right pointer, which will also be at 0, and loop will be where till my right is lesser than S dot. Okay, so now what we can do is we can should we reduce it directly from the frequency map, or should we increase it in our counter map? Which one will help me? Let's just not change the frequency map. Let's use the secondary map first. What we'll do, we'll increase this in our frequency map. We added this in our frequency map. Hmm. Reduced it from our frequency. We will be we need to know one thing. If I'll get that one thing, I don't need to use the secondary map. Now if I'm at this position, suppose that I'm at this position A, I I know I reduced the frequency from 2 to 1. So now I know that in future 1 is present. 1 character is present. 1 character of A is already is present. But how many I have iterated, that I don't know. Do we even require that? For that yeah, we require, because we need to fill 3. So 3 minus how many I've already seen in this sliding window. We have seen 1 till now, so we'll reduce it. We need 2 more, but here is only 1 more. We can say that we won't be able to make. So we'll reduce our sliding window. We'll start our left pointer and right pointer again from here. Will not consider this in my answer. correct. Now we have a B. So now as we reduced, we only have one in future, and this secondary map's frequency will also be reduced. If I have A as 1, we need to reduce it from 1 to 0. That means our sliding window has not encountered any A yet. Okay. What we'll do, we'll increase it in our counter frequency and also will reduce it from our main frequency. This will tell me how many are available in future, and this will tell me how many we have in the sliding window. Now the next part is are we satisfying this K condition? So for checking that we satisfying this K condition or not, we'll have to iterate our count map. I think there will be some better approach than this also present. Well, it is not equals to count dot, and if bool mm, answer is equals to false, sorry, let's say to true, if IT of second is lesser than A, K, answer will be set to false, and then we'll break from here. Now if answer is equals to true, then we'll keep it in my resultant maximum of R minus L plus 1. And then we'll return result. Now this is my checking condition. Now what I need to do, we need to check whether in future the frequency which we require at least is present or not. So in count, how many are present in the sliding window is there. So how many present will be given by count of S of R, and how many is available will give me the frequency of S of R. How many required? How many required will give me, shit, what happened? Okay, okay. Uh, how many do we require is total K minus present in our sliding window. So this is what is required. Now, if this requirement is not fulfilled, if REQ, if required is greater than frequency of S of R, that means कि in future got reset. Okay, no problem. So if required is greater than my frequency, that means we won't be able to. So what we will do, while my left is lesser than right, I'll remove everything from my count. So count of S of L minus minus L will be increased, and also I need to remove it if count of S of L is equals to 0. Count dot erase S of after every iteration. My let's see. Okay, I haven't declared an time limit exceeded. Why? Okay, for this I haven't done IT plus plus. Okay, so output is what we expected. Let's add one or more test cases. We let's make it 3. So okay, now this test case is failing. Okay, let's check. Let's check. Okay, this is what we can see here. Okay, let's try run this for once and see what we are missing. I don't think I think that this should work in any way. Let's try run this once. I'll shorten this code A B A B C and B B B C. Okay, so the frequency of A is in total 2. The frequency of B in total is 3, 4, 5. The frequency of C is 1. K given is 3. Correct. Let's try run. Now this is my frequency table map. This is my count map. So count contains A, count contains B, and contains C currently. So my left is at here and right is also at here. So my left and right is at A. Now A's frequency will be increased to 1. Now what we require is 3. Now this will also be reduced to 1. I'll say that how many we have in future. This is present in the window. So we have one A present in our window and we require one more A. Okay. Okay, okay. I forgot to add equal to sign. Let's see with some more test cases. B B B A S T C C C C C C C. Okay, as 5. It's working. Okay, let's try and submit it and see. 32 out of 38. We are very close. Let's see this test case. Why it failed? We have B B A C B D. This should be. But do we have a total of A count is 3, a total of B is also 3, a total of C is 1, a total of D is also 1. So we require one more D. Alba. Add one more base case for safety. Uh, which base case are you talking? If my k is greater than length of s, return 0. Huh, we can also even add that case, but mm, I think my code can handle that part also. Yeah, but we can add that case. That is also true. Length of s. Correct. Okay, I'll try and add that case also. But let's try run this and see why my code fails over here. Okay, so B's frequency is, my left pointer is here, my right pointer is here. So B we encountered, we still have two. Let's remove this. B's frequency is 1. K is 3. We require two more in future. We have two more in our future. What is present? We found out we require how many? 2, and if required is greater than, no, it's not greater than, so we can have in future B. That's fine. We'll move our right pointer over here. We have our frequency, this will be reduced. How many we require now? 1. We still have 1, so that's fine. We'll move our pointer here, A. At A, same thing, 3 will be reduced to 2 and 1. So we require 2, we have 2. Oh, okay. Now I got what I am doing wrong. We still have 1. And A is 2 twice. We require 1, it's fine. 0, this is 3. So we have a 0. Biryani day again. No, अभी तक तो नहीं. So my right pointer is here. My right pointer went over here at C. Now we reduce C to 0. C added 1. Now we know that C's frequency is 1 and we require 2 more. There the condition fails, and here we are reducing our L pointer to R pointer, but we during the reduction of time we need to check. Hmm. So R mm, this there is some problem. If when we are adding B over here, we know that there is a B present. So except this character, if all the characters has a frequency of 0, that means we'll have to check each and every time. But how will it affect my time complexity? Right here is not equals to phi t is not equal to reduced 1b 2b. Count became 0. We have only A and C in my frequency map. Okay, this should have worked. Why? If it ka second is not equals to s of r, we are checking it should not be equal to the current character because we know that this character is failing. And except this, if the second value is lesser than k, then answer will be false. But if it is not, if it is true, then we'll find the answer by r minus l only. My answer is still S so far. Should not be 0. But why? Why? We have R over here. We have this in our frequency map 3, 2, 1. We take this B and reduce it from here, that is 1. Now accept this. I only have 3 and 1 over here. Then I go again to this. I reduce this also to 0 and I remove this. So this time A's frequency is equals to. So it should not go in my answer is equals to false. Nice. Let's just try it on. I run this on a shorter example. Let's see what is happening. I have a B, A, and C. So B, A, C, and B. So my K is 3, this is 0, 1, 2, 4. This is my left, this is my right. Correct. I total have A as a frequency of 2, B as a frequency of 1, C as a frequency of 1. Sorry, B as a frequency of 2, C as a frequency of 1. Now I add this. Let's run it with the code also. I reduced it from my frequency, I add it in my count. Correct, I reduced it in my frequency. So B is 1, I add it in my count is 1. Now the present is count of S of R. So my present contains 1. What is required is 3 minus present, that is 2. Okay, okay, let's take K as 2. So 2 minus 1, that is 1 is required. 1 is required, and required is greater than frequency of S of R. So 1 is required and 1 is present in future. So this will not execute, it will go directly outside this if condition to check whether every character is lesser than greater than k or equals to k or not. So for now it will be not, and r directly my r will increase to the next here. So a, we reduce a by 1, we add a as 1 here. What now present a this was for b, this is for a. Present a is 1, what is required is 1. Do we have it? Yes, we have it. So it will not go in if condition, it will directly go for checking, but will not find anything. So my right moves here, this will be reduced, this will be increased. What is present for a again, that is 2. What is required is 0, is 0. It will not go to if condition again, it will move to the next pointer. Now comes c. C's frequency will be reduced, C's frequency will be added. What is required, what is present is 1, what we require is 2 minus 1, that is 1. We require but we don't have 1. So it now this will go in if condition, and this will go in while L is lesser than or equals to R. So count of S of L will be reduced, means B's count will be reduced to 0, and if it is 0 we'll remove this B. So this B has been removed from here. We'll move my B left pointer from here to here. Okay, before this my left pointer is here, I'll increase my left pointer from here to here. Now what we'll do is I'll start with it dot begin answer true, why it is not equals to, if it of okay, sorry, if it of second, okay, 36 out of 38. Hmm. This will fail. This will fail. because in my current, if it is 2 over here, there is a continuous. Think it will fail in some or other test case. Let's see how I solved this. I used recursion for this. Is it recursion? Recursion? Yes. But can we solve it using sliding window topics? It can be solved using sliding window, hash table, divide and conquer. Can be solved with recursion, but I need sliding window approach. No, I don't want recursive. Yeah, the frequency of each character. It is not that easy. Imagine that we have this. What should we do when we reached window AAB? Should we expand it, right, or should we start moving? One way to handle this problem is to do several sliding window passes. That is what we are doing. We are passing the several sliding window where we fix t number of different symbols we must have in our substring. So we check all possible. In fact, not 26, but number of element with frequency more or equal to k. What it is saying. Begin, end, found, frequency, more. Let me go with Strongest substring with n unique characters. Saying int map num unique num no less than k begin and while end is lesser than s dot length if map at caret I mean, can we improve our solution only? Can we improve our solution? How can we now do it? We have b as 2, we found we have a as 3. If it is not continuous, what if it is AAAB? BB and B. So, and then this will give me a correct answer. This will also give me correct. How can we think of something here? कुछ पता चले तो मेरे को भी बताना अलवा. ये रिकर्शन से बन तो जाएगा, रिकर्शन से हम सोल्यूशन इसका बना देंगे, बट मेरे को स्लाइडिंग विंडो से ही बनाना है इसका. इस वजह से सोच रहे हम क्या कर सकते हैं और इसमें ए ए बी ए बी ए ए बी ए बी बी डी डी डी. A B B D C. Why we are getting 6 as a correct answer? 1 2 3 4 5 6. We got D, but we still have 2 D's in future. So we'll go here C. Why it passed? Why this test case passed? This time it's 6. The only way it is failing is when we are having some continuous value. What we can do to handle this? Okay. For this continuous, we can handle it. We can even handle it before and before even going for the sliding window approach. We can do this, but we need something better than this. The office of V of I is greater than or equals to K. No, no, no. This won't help. The better way to solve this will be doing a sliding window approach with fixed number of characters, picking a character by character. We can think of uh, some other approach also. Let's think of some other approach. We know that we have a characters from A to Z. So first if we take one character at a time, we are only taking one character at a time, then this C, that means we are taking A. If we are taking two character at a time, if we are taking three character at a time, can we try this approach? Let's copy it. Let's try. Don't need comment. Start my IS1. I'll get till 26. Excuse me. Hmm. Result will be maximum of result. Find max length width. Constant character. So the constant character length I'll send the frequency map. Do we require frequency map? I don't think we require frequency map. We need to send S and we need to send K. this is my length, this is my string s, and this is my k. Now I need a map frequency. I don't need this here. Left is equals to 0. Okay, frequency of s of r plus plus. Now if frequency dot size is greater than length, if it went beyond let's make it while frequency dot size is greater than length, frequency of s of l minus minus l plus plus even frequency of s of l is equals to 0. So it is equals to well, it is not equals to frequency dot end. Flag is set to false. Okay. Mhm. Sorry. Okay. This time it worked. Let me put my submission test case also. Check. Great, it's working. Let's submit it and see. Fine, it's accepted. Nice. So actually I was thinking of not going with this approach, but I had to. I had no other option of directly going with sliding window. So in this case, what I am doing is I'm setting the frequency max limit. Means, for example, if we have this, as in my example, AB, so what we are doing is we are setting a length, like 1 is my limit. Means I'll I'll keep only one character in my map, not more than that. One character, whether it is A, B or C, I'll only keep A, B and C directly in my map. If I'm setting a length of 2, that means I'm trying to keep maximum 2 characters in my map, not more than 2 characters in my map. So either AB or BC or AC, this can only be possible. I'm directly applying the sliding window approach, that if it goes beyond my length, if if I'm pushing my characters in my map, A pushed, okay, till now my frequency size, my map size is lesser than a the fixed length that I have. I'll push B again. Still now my length is 2, and the map frequency length is also, size is also 2. We pushed A again, B again, B again. Now C comes. When I saw C, my length increased from 2 to 3. Now we don't want this, so what we'll do, we'll move my left pointer from here until and unless I remove a character from left side. So we can remove this A, these two A's, then we can remove this A's frequency. So now B, B and C will be in my map. So then we'll fix the length with 3, and this way we are finding out the answer. We are using the same approach that we were using earlier, but this time we are fixing length. So yeah, so this way we can solve this question. If you'll have any doubt, let me know. I'll explain it again in a more precise manner. Alba, were you able to solve this question? It's actually a very nice, very nice question. Okay, so now let's just take a 10 minutes break, and after that we'll start again. Still solving. Okay, try it. Let me know if whenever you'll be able to solve. I'll be back in 10 minutes. So we are back. Let's try and solve few more questions. So this question is really good. I would recommend this to everyone to solve this question. At least try it once because you'll get lots of idea whenever when you will solve this. So, okay, so now let's go with our pattern. So this was the sliding window, how we can approach this sliding window question. Before attempting this hard level, let's keep this hard level for a time, because it might be possible that it'll take a lot more time to solve this again. So let's see what is string anagram actually. String anagrams. Hmm. It is saying that given two string s and p, return an array of all the start indices of p's anagram in s. You may return answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letter exactly once. All the start indices of P's anagram. Let's solve it. Let's solve it. Let's not skip it. So the question is saying P, this is my anagram ABC. This is a string which needs to be matched. So output is 0. At 0th index, from 0 till 3 characters, I can see there is CBA. And if we shuffle this character, I can make ABC. Correct. Again, we have at 6th index 0, 1, 2, 3, 4, 5, 6. From at 6th index we have BAC. Now even if we shuffle this, we'll get a anagram of ABC. Correct. Now how to do it? Okay, we have AB. Now we can see the pattern matches again with the logic that it was saying. The logic was you're asked to find the longest, shortest substring, subarray, or desired value. So this comes in desired value part. This is not something a substring or subarray, but this is a desired value which I want from that data structure, and it's a linear data structure like array, linked list, or string. So this is a string data structure. So we need to figure out how we can approach this question. This was a linear and also a desired value, so we'll try and approach this with a sliding window approach. So maybe CBA. Now let's take this example as AB and AB, and we have pattern as AB. We need AB, and we are given this string. Now we keep this AB, in our pattern in a map, we know that A's frequency is 1, B's frequency is 1. We only need to find A, B and AB. If there comes a C in between, like AB, C, AB, so we have these two strings. Starting index is this and starting index is this. These are the only two strings possible. Hmm. So how to apply sliding window in this question also? So for applying sliding window on this, we do we require another map for this? We have this map frequency. We saw we saw an A, we reduce the frequency, correct. We saw a B, we reduce the frequency. Now all the characters frequency has been reduced to 0. That means one of my possible answer is I'll push my left in my answer. So 0 will be kept in my answer, left index. So left index is here. Now we saw a C character. C is not present in there. Now we know that we cannot move any further because this C is not a part of my answer. This C is not part of my answer. So we will not be considering C. Um, will move from here until and unless we remove this C. So we saw A will increase A, we saw B we increase B, we saw C till we reach this R pointer. We reach this R pointer, will move my left and right pointer over here. We saw A, we reduce it by 0. We saw B, we reduce it by 0. Now let's try with this case also. The case is AB AB. We saw an A, we increase the pointer. And we saw B, we increase the pointer. We saw an A again, sorry, it was 1 1. We saw an A at first, we decrease the pointer, not increase. We saw a B, we decrease the pointer. We saw A again. Now we'll decrease the pointer and we'll go to -1, but we don't want it to be -1, so we'll move my left pointer until and unless this -1 comes to 0. Correct. So it comes to 0 when I remove this A. So this now still they are 0 0. So with this is this point is one of the possible anagram. Now we again add b. B will go to -1. We'll remove this and we come here. Okay. So this is not going to be very difficult, I would say. The only thing that I need to remember or keep in mind is if it goes lesser than 0 or a new character arrives which is not part of this, then we have to do something. These are the two major things. The point one is if the frequency goes negative, then we need to do something. The second point is if new character arrives, then we need to do something. So in both the cases we need to do something. So let's try at first keep a unordered map of character comma integer. So we'll add this in our frequency of s of I plus plus. Correct. I'll create two pointers, which is left pointer and right pointer. Both will start from 0 and we need a vector int as my resultant to keep my results over here. Now while my r is lesser than s dot size, r will increase in every case. Now what we will do is we'll check for the first thing if let's check for the first case if it goes negative. No, let's check for the second case if a new character arrives first. Now for that we need to check can I just want to reduce the complexity for this. Original of s of I, sorry, plus plus. Now if frequency dot find, if I find this s of r is equals to frequency dot end, that means this character is not present. This will hinder our anagram thing. So for that what I will do is I will reset my frequency with my original map. I'll move my left pointer to r plus 1 and right pointer to increase, and then I'll continue if this is the case. If this is not the case, then frequency of s of r will be reduced once. And now while frequency of S of R is lesser than 0. If it is going lesser than 0, that means we need to do something. So frequency of S of L plus plus L plus plus. Now I'll check in my map. Hmm, let's try. Instead of keeping a flag, if it second is not equals to 0, that means we haven't found all the characters, then we'll break, else we'll move our iterator. Now if my it is equals to frequency dot end, that means it has reached the end of the frequency, that means all the values are 0. Then resultant dot pushback left. I'll push my left. Let's see. Okay, we are only getting one index. Why? Let's try run this once and see what has happened. So we are given AB, two characters. Now the pattern is AB. We have in our map A as A as 1, B as 1. Same is with my original. Original will also contain A as 1, B as 1. And this is my frequency. Now let's just iterate. This is my left pointer, this is my right pointer. Now the first character which came is I'm checking in my frequency table whether it is present or not. It is present in my frequency table, so this will not be executed. We'll skip and we'll go here. Frequency of S of R minus minus will reduce it to 0. While frequency of S of R is lesser than 0, it's not, so this loop will not run. We'll move further. It is frequency dot begin. So if it of second is not equals to 0, that means B is not equals to 0, so it will break and my frequency will not reach, my it will not reach to frequency of end, so will not push L. R plus plus, so my R will increase from A to B. Now this is also present in my map, frequency map, so we'll reduce this to 0. While frequency of S of R is lesser than 0, it's not lesser than 0, so we saw this is this will reach my end and will push it in my result. So result will be pushed. Okay. So give me 2 minutes. I'll be back in 2 minutes. Just give me 2 minutes. Okay, I'm back. So where were we? We saw that this is pushed in my answer. So we incremented our R pointer and it went to this A. This A is also present. It's not in. So we'll reduce the frequency this to -1. This is now though this frequency has been reduced lesser than 0. So until and unless it reaches equal to 0, I'll move. So frequency of S of L will be increased. So L is at this place, this will be increased to 0 and L will move forward. So S of R is now 0. So we are good to go. We check again. Frequency dot begin is not equals to 0. So both are again 0, so it will reach and it should have pushed 1 now. Uh, should have pushed 1. For every R, what is the value of L? For R is equals to 0, L is 0. For R is equals to 1, L is 0. 0, 1. For R is equals to 2, why L is 0 again? For R is equals to 3, L is 0 again. It should not happen. It's not going inside my while loop. Why? What's the problem? For 0, for A's frequency is 1. At this position, B's frequency is also 1. Why A's frequency is 1? Should have went to 0. Is it something prefix and postfix? No. Oh, oh, sorry. Should be pattern, not the original string itself. Hmm, My bad. Okay, sorry, my internet went was down. Yeah, so we were solving this question. See, let's submit it and see whether it is working or not. Accepted. Great. So this this is not that hard, I would say. So this question was way better than the previous one. Still fine. So we saw some sliding window question and good sliding window question. So I now I would say that let's jump to some other pattern also. Let's see what other patterns have. So the next pattern is two pointer or iterators. Two pointer is a pattern where two pointer iterate through the data structure in tandem. What this tandem is? Sorry, my English is very bad. Tandem meaning with two or more horses. But a bicycle with seats and pedals for two riders, one behind the other. Is it having two things arranged, one in front of other? Okay, two pointers is a pattern where two pointers iterate through the data structure in tandem until one or both of the pointers hit a certain condition. Two pointer is often useful when searching pairs in a sorted array or linked list. For example, when you have to compare each element of an array to its other elements. Okay, two pointers are needed because with just pointer you would have to continually loop back through the array to find the answer. This back and forth with a single iterator is inefficient for time and space complexity, obviously. A concept referred to as asymptotic analysis, while the brute force or naive solution with one pointer would work. It will produce something along the lines of O of n square. In many cases, two pointer can help you find a solution with better space or runtime complexity. Correct. So two pointer so the two pointer approach is something where we need to find an answer. Even we need to compare pairs. If there are two pairs in an array, you need to compare those pairs pair by pair. So one approach that we can think of is O of n square, where I fix one value and then we iterate over the other values. But this might take a lot of space and time complexity, which we don't want, which will cause problem. So what we will think of creating a two pointer. Maybe the two pointers will start from here only, or even the two pointers can start from start and end, and based on some condition we'll move the pointers left and right and compare the two values that is present on the pointer positions. So this might be one of the cases. Let's see uh, ways how we can identify whether it's a two pointer method. So the first thing, it'll feature problem where you deal with sorted arrays. So it might be possible if there is a sorted array, we can think of a two pointer approach also. So one more thing that comes in my mind, if it is a sorted array, we can think of a two pointer approach or a binary search approach, because binary search also gives uh, is applied over a sorted array only. So either two pointer approach, either binary search approach, we can try, we can attempt those. So it will feature problems where where you deal with sorted arrays or linked list and need to find a set of element that fulfill certain condition. So the first thing is sorted. So the first point that we found that it should be sorted. The second point is the set of element in the array is a pair, triplet, or even subarray. There are some problem that feature two pointer. The set of elements means the answer set, whatever the answer contains. Like if the two pointers are from here to here, if these are the two pointers, my answer set is currently this. So the answer set contains the set of elements array is a pair, triplet, or even a subarray. So it might be possible that it is a subarray. It is possible that these two are the pairs that we are finding out, or it might be possible that these three are the uh, triplets that we are finding out, something like that. So this way we approach the two pointer. The second part, what I would say is set of elements. Okay. So let's just take a look at some example. I'll not be solving the easy one because it will always be very much easy for us to solve. Um, Triplet that sum to 0. Comparing string that contains backspaces. Let's go with the triplets that sum to 0. That means I need to find a triplet that will sum up to 0. Let's see. Even sum to a given value also, or sum to 0, which is nothing but 3 sum in LeetCode. Alba, are you still there? No. So this question says I need to find three values where the I pointer, j pointer, and k pointer should not be same, and all the values should sum up to 0. These are the three values that we need to find. For this case, this is not very difficult question, I would say. I'll first sort the array because there is nowhere given that if changing or shuffling the array would hamper my answer. So this case will sort the array, and then we so this part is completed, sorted. Now we need to find the set of element. In this case we are finding a triplet. So for triplet what we'll do is we'll pick one element, we'll fix one element, something like this, and for the rest of the elements we'll move create a two pointers. We'll create two pointer from start, from end, and sum all these three values. If the value comes out to be 0, we'll move my left pointer and right pointer both left 1 plus 1 and right minus 1, and if the value goes beyond my 0, then I'll move my right pointer. If the value goes is lesser than 0, I'll move my left pointer. So this is very simple, and the time complexity for this will be n square, and n square is accepted because it's going 10 to the power 3. We can at max go to 10 to the power 6, so it's accepted. So let's solve this quickly, not wasting any further time. If you don't uh, if you didn't get what I said, let me know. I'll explain it very clearly again. So this is my fixed pointer. I'll contain left pointer which is at I plus 1, and I'll keep right pointer which is nums dot size minus 1, and this should not go because uh, I, L and R should not overlap with each other. So while left is lesser than R, now the condition is if nums of I plus let me store it somewhere. Nums of I plus nums of L plus nums of R. If sum is equals to 0, I'll push it in my answer. I haven't created answer vector. So result dot push back nums of I comma nums of L comma nums of R. Now my left pointer will increase, my right pointer will decrease. If sum is not 0, then if sum is greater than 0, then my right pointer will decrease, else my left pointer will increase. I haven't sorted the array. Okay, let's submit and see whether all the cases are correct or not, or are we facing any issue. Okay, we need not to repeat the character. We need not to repeat the character. I was thinking of this only. So if I is not equals to 0 and I is nums of I is equals to nums of I minus 1, if this is the case, then I'll simply continue. I don't want to compare those answers again. minus s minus 1 2 minus 1 0 minus 1. Minus 1 minus 1 2 minus 1 0 1. Minus 1 minus 1 minus 4 0 1 2 minus 1 minus 1 2. So if I'm at this position, my left pointer is at here, right pointer is at here. So they sum up to 0. Left pointer will go here, my right pointer will go here. Again they'll sum up to 0. So it's not in my answer. I increased my left pointer, I decreased my right pointer. Now still my left is lesser than my right. But why? These two values, this also should be in my answer. Minus 1 0 and 1. Why didn't? Oh, I forgot to add else if. प्लीज रिचार्ज घर का वाईफाई. ठीक है, अभी ब्रेक में करते हैं इसके बाद. व्यूअर्स कम तो हाँ, अभी किसी को पढ़ाई नहीं करना, क्या कर सकते हैं। If L is not equals to I plus 1 and nums of L and minus 1. Those duplicates needs to be handled properly. Without handling duplicates, it will create problem. But it's these two conditions are for handling duplicates. You need to handle duplicates in a proper way, else it will fail. Good, no issues. Okay, so now let's take a break for 10 minutes and then we'll start with some more patterns, or maybe I'll go with this or maybe not. Let's see after break. I'm back. Okay, so let's solve some more question. Mm, should I solve this? Compare a streak that contain backspaces. Backspace string compare. Oh, it's an easy one. Let's not solve this. It's easy. We'll be able to solve this. Let's jump to the next pattern, which is fast and slow pointer. The fast and slow pointer approach, also known as hare and tortoise algorithm, is a pointer algorithm that uses two pointer which move through the array or sequence or linked list at different speed. This approach is quite useful when dealing with cyclic linked list or arrays. By moving at different speed, the algorithm proves that the two pointer are bound to meet. The fast pointer should catch the slow pointer once both the pointer are in a cyclic loop. So it is saying that if there is a cyclic loop between a fast pointer and the slow pointer, then we will be able to find the loop. From where exactly the loop is starting. How to identify when to use the fast and slow pointer. The problem deal with a loop in a linked list array or array. So if there is a linked loop in a linked list or an array, then we can find the fast. We can use the fast and slow pointer for this. When you need to know the position of a certain element or the overall length of the linked list. When should I use it? The over the two pointer method mentioned above. When you need to know the position of a certain element or the overall length of the linked list. Okay, so if I need to know the length of the overall length of the linked list, we can use fast and slow pointer, or we need to find the midpoint of a linked list. We can even use the fast and slow pointer, which will help in finding the midpoint in one pass. We can even not use the fast and slow pointer, but it will take two pass to find the midpoint, but using fast and slow pointer we can find. Okay, for this let's pick a cycle in a circular array, palindrome linked list. Cycle circular array loop. Okay, let's try this. You are playing a game involving a circular array of non-zero integer nums. Each nums of I denote the number of indices forward backward you must move if you are located at index I. Okay, I am located at index I. That position value, each nums of I denote the number of indices we need to move forward or backward you must move if you are located at index I. If nums of I is positive, move nums of I steps forward, and nums of I is negative, move nums of I steps backward. Since the array is circular, you may assume that moving forward from the last element puts you on the first element, and moving backward from the first element puts you in the last element. A cycle in the array consists of a sequence of indices, sequence of length k. A A cycle in the array consists of sequence of indices, sequence of length k, where following the movement rules above result in the repeating index sequence 0 1. Okay, every sequence of j is either all positive or all negative. K is greater than 1. Return true if there is a cycle in nums, or false otherwise. Okay, so let's take an example and see what exactly are we seeing. So we have a 2, negative 1, 1, 2 and 2. It contains indices 0 1 2 3 4. Now every indices is telling me something. So this index is telling me that we can jump from 0 to 0 plus 2, that is 2, from here to here. This is telling me we can jump from 2 plus 1, that is at index 3. This is telling from 3 plus 2 we can jump to uh, 5. That will put me in at the beginning. And this is telling me that I can jump from 4 to 2, that is 1. So, and this is telling me that I can jump from 1 to minus 1, that is 0. So I can see that there is a loop 0 2 3 0 2 3 0 2 3. So the graph shows that the indices are connected. White nodes are jumping forward while red is jumping backward. We can get stuck in the loop that is this. This is the loop where we will get stuck at. So we need to find something, uh, some way to figure out how to identify this loop. Hmm. So we can use the fast and slow pointer here, and how we will go with the fast and slow pointer. 'Self loop is not allowed'. 11 modulo 6 will give me 5 index again. There is a self in the graph. The only cycle is of size 1, so we return false. Okay, it is said that 0 1 0, and while it is of size greater than 1, it has a node jumping forward and a node jumping backward. So it is not a cycle. What does that mean? Means I need to find a cycle where either they all are jumping backward or all are jumping forward. Eh, all positive or all negative. Then we are considering it as a cycle, else we are not considering it as a cycle. Okay. Okay, so how can we approach this? Okay, so I need to find all positive or all negative. Either all positive, either all negative. Okay, let's dry run uh, any one of them and then see how we are not going for the negative and now we are going for the positive. So 1 minus 1, 5 1 4. So this is 0 1 2 3 4. It is saying jump to 1. So this is a forward jump. I know from index 0 I can do a forward jump. So if there is a fast and slow pointer, so slow pointer will do one step and fast pointer will do two step. So fast pointer will come over here and again fast pointer will come over here and slow pointer will come over here again. So we know we if the fast pointer and slow pointer meets, then we know that there is a loop between 0 1 and 1 0. Now the next is 2 at index 2 we haven't touched 2, so 2 plus 5, that is 7, 7 modulo 1 2 3 4 5 5, that is 2. We'll come back to 2 again. So slow pointer and fast pointer will meet at the same position. So 2 also has a loop. Now from 1 I can jump to 3 plus 1, that is 4. My slow pointer will go here, my fast pointer will go 4 plus 4 8, 8 modulo 5, that is 3. So my fast pointer will move here, and then in next part my slow pointer move here, my fast pointer will move again here. So again there is a loop. But there is a difference between this loop and there is a difference between this loop. What is the difference? They are jumping forward and backward, and they are in this case they are not jumping forward and backward, they are actually jumping forward only. So this is considered in my answer, but this is not considered in my answer. So how to identify which one to keep in my answer and which one to not keep in my answer? Let's track this. From 0 I can jump to 2. So from 0 to 2, from 2 to 3, from 2 to 3, from 3 to again 0. Now I haven't touched 1, so from 1 I can jump to 0, and from 4 I can jump to 2. This way I can create a graph approach. Okay, in this case from 0 I can jump to 1, from 1 I can jump to 0. But this is a backward, this is a forward. I should not, I came from a forward position, I should not go backward. Now 5 to 5, then from 3 to 4, and which is forward positive, and from 4 to 3, which is also forward. So they both are forward and there is a loop, 3 to 4 and 4 to 3. There is a loop between 0 to 1 and 1 to 0, but they are forward and backward. So there should not be any backward, correct? A cycle is consist of a sequence indices sequence of k. Since the array is circular, you may assume that moving forward from the last element. Okay. A cycle is in the array consists of sequence of indices sequence of length k. If following the movement rules above result in the repeating index sequence. Sequence 0 to sequence 1 to sequence k minus 1. Again back to 0. Every nums of sequence of j is either all positive or all negative. Okay, okay. So it should be all positive or all negative. Should not be. So I can create a graph kind of and then do a DFS traversal and and then we can see why in the second output false. It's forming a cycle at sixth index. Yeah, correct. It is forming, but it is saying that the only cycle is of size 1, so we return false. So we have to have a cycle which contains at least values greater than 1. Then only will be saying that okay, it is a not it is a cycle, else it is not a cycle. Okay, in fast and slow pointer I can directly create a quickly I can create a graph for this. An ordered map of integer and it will contain vector pair of integer and a character. Because I need to know whether are we going backward or are we going forward. Okay, so int jump to where I am jumping will be nums of current index plus nums of I, which will give me where we are jumping to, and this jump to should be moduloed by n, because if it goes beyond Now there is one thing that I need to handle. If if I'm at position 0 and I have a value of -2, suppose. So 0 plus -2 will give me a -2, and -2 modulo 1 2 3 4 5 5 will give me what? 1 2 3 4. It should actually go to here. So -2 modulo 5. Let me check. -2. Oh, it is a returning boolean. Can I check it somewhere else? Here, vector, vector. There it is returning integer. So instead of returning this, let me return this. So -2 modulo 5 is giving me modulo. So this we need to plus n modulo n. So this way it will give me what? Modulo 5 plus 5 and then again modulo 5. This should give me 3. Which is correct. And if it is a positive 2 modulo 5, well, it should again give me 2. 2 only. Correct. So fine. So I can jump to that place. So m of now depends on the condition whether I'll be doing forward. So from here, from this index, I can jump to which index? So m of I dot push back, jump to this index, and it depends if absolute value of no, no. If nums of I is greater than or equals to 0, if this is the case, then forward or else backward. Check if it is working. Hmm. Now I will do what I'll iterate over each of the vector and visited. Visited will be of size, say, visited of I is equals to -1. That means we haven't visited this value. Will do what we'll call DFS here. So if DFS returns true, I'll return true, or if it is returning false, and then we'll check. So DFS will have this map, this visited, and the position from where I'm starting. So this DFS will return a bool value with src with this map and of visited of srcs is not equals to if I came to that place again. If I came to that place again, that means there is a cycle. And also that index contains a positive value or negative value will decide whether if I go to a position where it contains a backward which is not matching It also correct contains a character dirs direction. Direction will be what? Mm, the value. If char direction will be if nums of I is greater than or equals to 0. If this is the case, then forward, else backward. I'll pass this direction also. Okay. Visited of SRC, set it to 1. Now for int I is equals to m of src dot so new direction as should be equal to the given direction. So m of src of I dot second is the new direction. If new direction is equals to the given direction, then only we are moving, else we are not moving. So from 0 I visited to 0 will have a value 1, visited 2 will have value, visited 3 will have a value, and from 3 we are again visiting 0. So if visited of src is equals to 1, this case I'll return true. That means we found a cycle. So we don't need this. Let's, if direction is same, I'll just call that. I'll directly call src the new direction. Rent new position will be m of src of So we'll go to new position. We have map as it is, we have visited as it is, and direction will also will remain as it is. Equals to true. Now if it is returning true, I'll return true from here, only else return false. Let's see. Okay. But why it got accepted? This I didn't handle this case. Shouldn't have shouldn't should not be accepted. Should say yes. I knew that. 35 out of 44. On one case was not being handled here. That needs to be handled. It's expecting if it would have been submitted, then there must be something I didn't understood. But till my understanding, it should have failed at some position. This is 5 plus. Uh, uh, what it is saying, 0 plus minus 1, which is -1, -1 plus 5, which is 4, and modulo 5, which will give me 4. So from 0 I jumped to 4. Now 4 minus 5, that will give me -1 plus 5, that will give me 4. Modulo 5. From here I jumped to 4, and from 5 I jump. I'm looping on 5. I'm looping on 5. This is a self loop. From here also I'll jump to 4 and 5 will loop. From 3 also I'll jump to this index and this will do a self loop. From 5 also we jump to this index and this will do a self loop. Let's just not include the self loop only. Uh, if I is equal is, I'll only push. I'll remove the self loop wherever we are getting a self loop. If I is not equals to jump to, then only in this case we are not considering the self loop, then it's saying false. Let's see if it is failing in any other test case. 42 out of 44. Boy, it's negative 1 2 1 2. Expected it true and what I got is false. 0 1 2 3. From here I can jump to the 3 plus 2, that is 5. 5 modulo 4 will give me 1. So from here I can jump to here, but this is a positive value, so it will not go. From 1 plus 2, that is 3. I can jump here. Where is my DFS? So if I break directly, I'll not go. The last 2-3 cases are all problematic. -2 1 -1 -2 -2. 0 1 2 3 4. Expected is false, mine is returning true. Why? From 0 -2 I can jump. From here I can jump here. From say 3 index -2 I can jump to position 1. From 1 plus 1 I can jump, but this will not jump because the direction is changing. I had a negative direction, but this is a positive direction, so this will not work. From here I cannot go. So from 1, let's see, from 1 plus 1 I can go to here, and again the direction is changing. I should not go. 2 minus 1, that is, it is going here. Again the direction is changing, should not go. This is already giving me a wrong. 4 minus 2 is 2. 2 minus 1, which is 1. In any case it is not going. Why we are returning true in this case? It should not return true. Why? me see what is happening in my visited array. Initially everything is if it is already visited or not, so visited of 1, so I made this as 1. I updated it to 1, that I am visiting this. From here I can jump to 3, so I jumped to 3. New directions are matching. I jumped to 3. 3 is not visited, so I'll make 3 as visiting. So from 3 the new position is 3 minus 2, that is 1. So the new position is this, and its direction is not correct, so will return false from here only, that there is a wrong direction that we are going. Now we picked this, we made this as 1. From 1 I can jump 1 plus 1, that is 2. Now second index direction is opposite, is not correct, so will return false. From here I'll jump here, I'll make it as 1. From here I can jump to this position, but this index is direction is not correct, so I'll return false. From here this is already visited. From 4 minus 2 we will jump to 2. Oh, okay. But if I'm doing break, it should pass the last test case, but it is not passing the fifth one. Minus 1 2 1 2 0 1 2 3. Okay, from 0 minus 1 it will take me here. 1 2 3 negative 1 negative 1 negative 1 negative 1. From 0 to minus 1 it will take me here. I have visited this. Okay, from 1 I went to here, but the direction is changing, so else we break and we make this as 2 and return false. Now from 1 to 2, 1 plus 2, that is 3, so I'll make this as 1. We've jumped to 3. 3 plus 2 still has a positive. So 5 1 2 3 4 will give me 1. 3 plus 2, that is, sorry, 1 plus 2, that is 3. No, 3 plus 2, that is 5. Modulo will send me to 1 again. 1 is already in a visiting state. Direction is also same. It will return me true. I'll return true. Hey, it should return true now. Why it is returning false? So I made this as 1. Why? Shouldn't be happening. Visited FSRC is 1, return true. So for 0, my this direction is backward, which is giving me to go at position 3. So from M of I, that is 0, we can jump to 3. 3 has a po positive value. Hmm. It's only doing mistake over here. Wherever I'm jumping from here, from this position, I'm jumping to this position. So this position's value is a forward direction, and this position's value is already I'm taking in my direction. Yeah, that's why I was facing some issue. No problem. So finally, we figured it out how to solve this. This is very much related to graph also. I don't know. We can also solve it using pointer, slow and fast pointer. And this was very much related to slow and fast pointer also, only because 1 and 2 we were taking it. If it is 1, we are already in a visiting state. If it is 2, then that means we have already visited it and we don't have to visit that again. Cool. Okay, so we are very much good to go to next question, but let's take a lunch break, and after lunch break I'll be solving more questions. So for now, let's take a long break because I have to order something today. Cook has not came, so I'll be ordering something online, and I'll see you after lunch break. Hello. Hello. Okay, so I'm back. Let's try. Let's solve some other questions also. We'll I got a new mic stand over here. I don't know if you are able to see or not. There it is, a new mic stand. Finally, I was waiting for this so long. Now it is here. So I'll be using this mic stand for now. Okay, let's go. So we were solving some two pointers, fast and slow pointers. Now let's jump to merge interval. So for the merge interval part, it is saying the merge interval pattern is an efficient technique to deal with overlapping intervals. In a lot of problems involving intervals, you either need to find overlapping intervals or merge intervals. If they are overlapping, the pattern work like this. Given two intervals A and B, there will be 6 different ways the two intervals can relate to each other. Just give me a second. Okay, so I'm back. Okay, so basically the merge interval part is nothing but we need to find whether the intervals that we have, whether they are overlapping or not. So for example, if I take an example of overlapping interval, we have two intervals over here. Let's suppose 1, 2. This is a not 1, 2. Let's take 1, 5, one interval, and there is another interval which is going from 2, 6. So we can see that from 1, starting from 1, we are going to 5, and the other one is starting from 2, we are going to 6. So they are overlapping. There is some common part in between them. So you can see over here there are some common parts, and we somehow have to merge those intervals, and the final resultant will be 1, 6. Instead of writing two separate intervals, we can directly write a single interval. which is 1 comma 6. So this way we can solve this these merge interval question. There are a lot many questions that that can be made using merge intervals. So let's see what the pattern in which we can identify whether this is a merge interval or not, whether to use merge interval or not. So it is saying that if you are asked to produce a list with only mutual exclusive intervals, if you hear the term overlapping intervals, merge interval problem patterns. So it is saying that if you are asked to produce a list with only mutual exclusive intervals, mutual exclusive intervals means we need to remove all the overlapping intervals. Mutual exclusive means if we are getting any kind of things which is related to intervals, we can think of merge interval at first, and if it is not fitting or we are not getting any idea about merge interval, then we can go with some other approach also. But at first I think merge interval will always going to be a better approach for this. Okay, so the question is interval intersection and maximum CPU load. Okay, so let's go and solve any one of them. Should I go for maximum CPU load or should I go for intervals intersection? Let's open both and single threaded CPU. And the other one was intervals intersection. We also have a direct merge intervals on LeetCode question. Let's copy this and search this also. Interval list intersections. Okay, so I've already solved this merge interval many a time, so I think this will be very obvious if I solve this again. So if you want, let me know. I'll explain this merge interval question again to you, and also even if you want, then I can solve this question also. But for now I'm not proceeding with this merge interval part. Let's try and solve this interval list intersection, and then maybe we can go for single threaded CPU also. Fine. So it is saying that we are given two lists of closed intervals, first and second list. They both are closed intervals, so they both are being included in the interval start I and end I. And the second list j. Okay, there are two interval list, first list and the second list. Each list of interval is pairwise disjoint and in sorted order. So it is already given that they are in sorted order. Return the intersection of these two intervals list. Okay, I need to return intersection of these two intervals. So I can see the first two intersection, the first interval and the second interval are overlapping. So if they are overlapping, the one whose we need to find the overlapping part, and the one who has a lesser value on its ending will be moving forward. Like for example, if I have this A, I have this as this A interval and this B interval. There are two separate intervals. What we can do is we can see that they are being overlapping. So for overlapping cases, we can check its end point and its starting point. If they are colliding with each other, means if end point is greater than my start point of the second interval, then that means this is an overlapping interval. So what we can do, we can find the what portion of it is overlapping. So what portion will be giving, the portion will be given by maximum of start I comma start of j. This will give me the overlapping interval, and the second will be minimum of end of I comma end of j. These two will together give me the overlapping part, which will be inserted in our answer. Now whosoever will have its endpoint less will be moving forward. So this will be moving forward. So I'll be moving to the next one. I can even see this, its starting part and its ending part is still overlapping. So we'll find the overlapping part and we'll put it in our answer, and whosoever will have its ending point lesser will move forward further. So I'll move this pointer next, and then we'll find the overlapping. This will be moving forward next, and then we'll find overlapping. This will be moving next. Then we'll find the overlapping part. This will move next. We find an overlapping part. We move next. We find the overlapping part, and whenever any of the pointer goes beyond the array size, we can stop from there. So let's try and solve this question and see how we can approach. So we have a given first list and the second list. So we'll declare two pointers, that is I, which will start at 0, and j, which will start at 0. So we are already given that it is a sorted list. So it will be sorted on the basis of first index. So we don't have to sort the list. So let's take maybe I'll use while loop while I is lesser than first list dot size, and then j is also lesser than second list dot size. So if they are lesser, I also have to create a answer. So I'll create a resultant vector. Now this resultant vector will contain all the values which I want to be in my answer. Now what I will do is I will iterate one by one and see whether they are overlapping or not. So I'll start with the end of first list. So okay, let me check for the colliding part. So if the interval is something like this, we know this end point is greater than this start point, correct? Now if somehow my interval is like this, so its end part is still greater than this start part. But if it happens, if it happens that they are not colliding with each other, so its end part is greater than its start part, this is true, but start is not lesser than this start. That means we need to figure out some way to make 100% sure whether any of them interval is overlapping or not. Okay, you can see we can have a case like this. We can also have a case like this. So this case will be handled if I check whether my end of I, let's suppose this is start of I, this is end of I, this is start of j, this is end of j. So if the end of I, first case will be if end of I is greater than start of j or even equals to start of j, then we are having an interval, overlapping interval possibility. Then there is a possibility of overlapping interval. Now the second the condition should be the start of I, start of this is my SI, EI, SJ, EJ. End of I is greater than or equal to S of j, then there is an overlapping case. Let's take both overlapping case. These are the two. So S of I, end of I, start of j, end of j. So if end of I is greater than or equals to start of j, this is also satisfying the same case, this is also satisfying the case. Now in this case what is happening is end of j is greater than start of I. End of j is greater than or equals to start of I. Is it end of j is greater than or equals to start of I? Yes, they both are following these two rules. Now let's check whether if we have some interval and they are not sorted, they are not overlapping, whether they are satisfying this condition or not. So this is start of I, start of j, sorry, end of j, start of j, end of j, start of I. So the first condition is end of I. End of I is greater than start of j. Correct. Okay, these two are overlapping case, these two are not overlapping case, where SI, EI, Sj ej. So end of I is greater than start of j. It's not true, so it will be false. Now in this case, end of I is greater than start of j is true. First case is satisfying, but the second case, end of j, should be greater than start of I, is not satisfying. Okay, so we can use these two cases, and if these both cases satisfy, that means we can say that this is an overlapping interval. So let's track start of I, start of I, first list of I of 0, end of I will be also be first list of I of 1, start of j will be second list of j of 0, and end of j will be second list of j of 1. Correct. So we found out all the values. Now we'll apply these conditions over here for overlapping. So for overlapping, we need to find end of j. If end of j is greater than equals to start of j, sorry, end of I is greater than equals to start of j, and then end of j is greater than equals to start of I. So this is the overlapping case. So if it is a overlapping case, what we have to push in our answer something. So end merge start will be maximum of start of I, start of j, merge end will be minimum of end of I, end of j. So these two are merge start and merge end. Now this will be pushed in my resultant. It will be merge of start and merge of end. Now I'll check with if end of I is greater than end of j, that means I is 1, so then I'll increase my j pointer plus plus, else I'll increase my I pointer plus plus. And finally what we'll do, we'll return my result. Let's see if everything is okay or not. Okay, so the first case is passed, second case is also passed. Let's try and submit it and see whether we are correct or we are wrong. Correct. Nice. So this is one way to solve this question, interval list intersection. So, and it was quite interesting question, but I think my perspective is merge interval questions are not very hard questions. We just need to figure it out how we need to move our pointers from left to right or from here to there and something like that. So then we are good to go. So I don't think we need to solve this single threaded CPU also, because that will also be not very difficult question. Okay, so let's just move to the next pattern, which is cyclic sort. So cyclic sort, this pattern describes an interesting approach to deal with problems involving arrays containing numbers in a given range. The cyclic sort pattern iterates over the array one number at a time, and if the current number The cyclic sort pattern iterates over the array one number at a time, and if the current number you are iterating is not the correct index, you swap it with the number at its correct index. So you could try placing the numbers in its correct index, but this will produce a complexity of O of n square, which is not optimal. Hence cyclic sort pattern. We can, means if we want to sort an array, we can, if in a special condition. Let me explain you the condition also. If there is some special condition, then we need to sort the we can sort the array in O of n time complexity, and the condition is I have been given an array of size 4, 5. Suppose 6 is the size of the array. So the element that is present inside these index should be in a given fixed pattern, should be from 1 to 6 only. If there are values which are ranging from 1 to 6 only, then we can say that we can sort this array very easily using cycle sort. Now using cycle sort. So here also it is given in the example that we are given 1 0 1 2 3 4 5. So total six empty spaces are there, and we are filling all the values with the numbers that are within the range 1 to 6. We are not going any more than that. So in that case, sorting will be very much easier. So now how to identify the pattern? There will be problems involving a sorted array with numbers in a given range. So there will always be a number which are in a given range. These are very important things to remember. If number 1 is numbers given in a range, if the problem asks you to find the missing duplicate smallest number in the sorted rotated in the sorted or rotated array, problems featuring cyclic sort. So the second is, if the problem asks you to find the missing or duplicate a smallest number. So in this case we can go with cyclic sort pattern. So okay, so let's just try and attempt a question which is find the smallest missing positive number. Okay. Let's try and attempt this question and see how we can approach this question or how to solve this question. So let's understand the question and match it with the pattern that we discussed right now. So we are given an unsorted integer array nums. Return the smallest positive integer that is not present in nums. So we need to find the smallest positive integer that is not present in nums. You must implement an algorithm that runs in O of n time and uses O of 1 auxiliary space. Okay, so let's understand the question with some example and then we can move forward. So the given example is let's take this third as an example. We are given 7, 8, 9, 11 and 12. So the smallest positive number that we can have will start from 1, then it can go to 2, 3, 4, 5, 6, 7, 8 ... This way the smallest positive number can go. So it's an integer that we are talking about and not any other decimal values. So the positive integer is 1, 2, 3, 4, 5, 6, 7, 8. Now the question is saying that we need to find the smallest positive missing number. We can see here 1 is missing. We are starting from 7, 8, 9, 11, 12, but 1 is missing and 1 is the smallest positive number that we can have. So we'll directly return 1. Sorry. So we can directly return 1 from here. Now the second, let's take this example and understand this 3. It's given 3, 4, minus 1 and 1. So if we can see that 1 is present over here. Smallest positive, we need to find the smallest positive number. It's directly given, find missing positive number. So missing positive number will always start from 1. So there is no role of minus 1 over here, because minus 1 will never be considered in our answer, because answer always contains a positive number. So negative 1 has no role. 1, 3 and 4. So there is a number that is 2 which is missing in between this 1, 3 and 4. So we can return directly 2. Now in the first example that we have is 1, 2 and 0. In this case we can see that we have smallest positive number is 1, we already have 1. Smallest positive number is 2, we already have 2, but we don't have 3 here, correct? So we need to find a way to solve this question in O of n time and O of one auxiliary space. If I would have taken some space, I could have used a hash map where I can store all the positive numbers, and then we can start from 1 to and check all the numbers whether they are present or not, but we don't have to do that. We in this case we only have to use O of n time algorithm and keeping it in hash map in a sorted way, and even hash map will take some space, so auxiliary space is not allowed. So we need to figure out some way to solve it without using some auxiliary space, and even in O of n time complexity. We could have done what if it was not given any O of n time complexity, we could have directly sorted this array and found out the smallest missing positive. But no, in this case sorting will give me n log n time complexity, and that is not allowed. So we need to find some other way. Let's see how we can do it. So we are given let's take this as example 3, 4, minus 1 and 1. Also let's take one more example to understand some 2, 3, minus 1 and 1. 2, 3, 4, 1, something like this. So let's understand each of them one by one. So it's given we have array 3, 3, 4. So there is no role of minus 1, so minus 1 will never play a role in our answers. So we have 3, 4, minus 1, 1. So instead of minus 1, let's mark this minus 1 as 0. We don't want this as in an our answer. We can take another example 2, 3, 5 and 1. Let's take this also. Okay. So this is saying that there is a number 3 available. So at position 3, I can tell the position 3 that you are available here somehow, if I can tell him. Now position 3, it's a 1 based index, so position 3 will tell at position 2 that value 3 is present. For 4 it will go to position 3 and it will say value 4 is present. For 0 it will go to position 0 and say that okay, value 0 is present. For 1 it will go to position 1 and it will say okay, value 1 is also present. Okay. Let's take a array for a better understanding. A separate array. Let's take a 0 1 2 3. If I can reduce this to 0 based index, it will be much easier for me to understand. Okay, so it is saying that value 2 is present, so at index 2 I'll mark this value as negative 0. That won't affect anything, but still okay, we are marking this as negative 0. 3, this will also be 0. 2 3 is still there. We haven't found out the 0 and 1 till now. So if 0, you can say that 0 is present, or even don't consider this. Maybe we can make everything as negative 1. I'll just skip. Okay, let's make it 0. No, make it negative 1. So 0 0 is present, I'll mark this as negative 2. 0 is present, I'll mark this as negative 2. So there is only one number which is positive, which is at index 1. I'm not concerned about the value because I have already considered this value over here. I'm only concerned about the index. This index is 1, and it is a 1 based index, so our answer will be 1 plus 1, that is 2. So in this case 2 will be returned as our answer. Now this was one way to solve. The other way which we can go is 2 3 minus 1 and 1. 2 3 minus 1 and 1. So let's make it a 0 based index first and solve it. So 1 2, this will be 0 and this will be 0 again. 0 1 2 3. So it is saying we found 1. This is saying absolute of this is saying we found 2. This is saying we found 0. This is saying we found 0. So there is a value which is 3. So we'll return 4, which remained positive. Okay. Now comes 1 2 3 4. So we'll make it 1 2 3 and 0. This will say at index 1 is present, so it will be minus 2. This will say at index 2 is present, this will be minus 3. And this will say this is present, so it will be minus 4. We'll say this is present, so it will be minus 1. So minus 1, minus 2, minus 3 and minus 0 also. So every value is present over here, so we'll return directly size 1 2 3 4. In this case what we can see is, let's make it 1 based index 1 2 4 0. So in 1 2 4 0, you can see 1 is present, so this will be minus 2. 2 is present, this will be minus 4. 4 is present. 4 is already beyond the array size, so I'll make it 0. 0 is present, so this will be minus 1. If I don't make it 0 based index, that will give me a better answer if I am not making it 0 based index. So let's solve it. So yeah, we have n is equals to nums dot size will iterate over this and if nums of I is lesser than 0, then make that nums of I is equals to 0. Now if nums of I is greater than or equals to n, make that nums of I is also equals to 0. We don't want those to be in my answer. Now what I will do is I will iterate. Now if nums of I is equals to 0, I'll simply continue because I don't want that value. That is not considered to be in my answer. Now position will be nums of I minus 1. This will be now my index where it is going. So wherever we are going, this index is taking, I'll take I'll have to take absolute value because that might be possible that it is a negative 1 value. So position is, this is the new position. Now if the new position is already negative, if the nums of position is greater than 0, then make it nums of position is equals to into -1 if it is greater than 0. If it is not, leave it. Now for int if nums of I is greater than or equals to 0, return I plus 1, else return n. Let's add 1 or 2 more test cases and see. 1 2 3 4 6. Why? Let's submit and see. We need to handle this 0 separately. That first has happened, first has occurred, like if nums of I, we need to handle this separately. Bool first is equals to false. If nums of I is equals to 1, so first is equals to true. First is equals to true, Now here, if before going anywhere, I'll check if first is equals to false. I'll directly return 1. So the last test case should now be handled. The question is saying 103302. 4 and 5. So we have the first we never saw one. We saw one. So make itself negative. So it made itself as negative. So it is now -1. Now this is 0. I'll simply continue. Nothing to do here. That is 1 present. So if it is 0, if I'll continue, I won't be. If the value is greater than 0, then just negative it. If it is 0, make it -1, because I'm not going to that value ever again. If it is greater than 0, else if nums of position is equals to 0, make it as -1. These all silly mistakes shouldn't be done. I'm forgetting few edge cases. These all edge cases needs to be handled properly. No problem. Okay, so this is the first missing positive solved. Great. So we worked with cyclic sort also. So next we'll jump with in place reversal of linked list after a short break of 10 minutes. We'll see you in 10 minutes. Okay. Okay, I'm back. Let's solve some more questions. Still have some time left, 1.5 hour approx. So we'll try to solve as much as questions in this 1.5 hour. Let's go. So the next pattern is in place reversal of linked list. So it is saying that in a lot of problems you may be asked to reverse the links between a set of nodes of a linked list. Often the constraint is that you need to do it in place, that is using the existing node objects and without using extra memory. This is where the above mentioned pattern is useful. This pattern reverses one node at a time, starting with one variable current pointing to the head of the linked list and one variable previous which will point to the previous node that you have processed. In a locked step manner, you will reverse the node current node by pointing it to the previous before moving to the next node. Also, you will update the variable previous to always point to the previous node that you have processed. So we are given my current is here, my previous is null, so my 2 will point to null, which is previous. Now my previous will be current and current will go to next. So the pattern to figure it out is if you are asked to reverse a linked list without using extra memory, problem featuring in place reversal of linked list pattern. I say this is not very difficult. It's only we need to figure the pointers, how we are moving the pointers and how we are ordering those pointers in some specific pattern. Like here it is previous and current we need. So we have to do something like that. So maybe I'll skip this in place reversal of linked list for now. In future, if you want, we can directly jump to that in place. Okay, let's go to the tree BFS. Tree DFS. Okay. In this pattern is based on the breadth first search technique to traverse a tree and uses a queue to keep track of all the nodes of a level before jumping on to the next level. Any problem involving the traversal of a tree in a level by level order can be efficiently solved using this approach. The tree BFS pattern works by pushing the root node to the queue and then continually iterating until the queue is empty. For each iteration, we remove the node at the head of the queue and visit that node. After removing each node from the queue, we also insert all its children to the queue. Correct? How we identify tree BFS pattern? If you are asked to traverse a tree in level by level fashion or level order traversal. Level by level zigzag traversal. Okay, this way, this is a tree BFS approach. If I can say, this zigzag traversal and this level by level traversal is not very much hard. Tree BFS. Let's search some tree BFS question. This is not a tree traversal. Tree BFS technique and question bank. Let's see if we let's see. So populate each next pointer to point to its next right node. If there is no next right node, the next pointer should be set to null. Initially all next pointer are set to null. Okay. Root is equals to 1 2 3 4 5 null 7. The next pointer for 1 is null. The next pointer for 2 will be 3. 3 will contain null. Okay. Let's solve this one. This is saying that we have 1, its next is null. We need to populate the next. We have given 2, we have given 3. It's all next value is null. We need to populate all next value with the next node present to it. So if there is 4 and if there is 7, we need to connect 4 with 7 and 7's next is null. Should be null. Okay. So if we do a level order traversal here, what we can do is we have 1. We'll push 1 in our queue. We'll pop this 1. There's no value behind this, so we'll directly push its child that is left and right 2 and 3 present over here. Now after this I'll pick 2. Suppose there is a value 5 over here for now. So we have 3 in the top, at the top of the element. So we'll pick 3. If we have any element still left, we'll connect that with this one, and this next will be empty. We'll pop this out. We'll push in the array its left and right. That is 5 and 7. Just a second. We have 1. We pop this out. We push it 2. We push it 3. We pop this out. We connected 2 with 3. So we should push it backward. Don't you think so? We should push it backward. We can use DQ for this. If Q is not working, then DQ can do the job. So we have 1. We'll push 2 and 3. And 3 in the back of this and pop this out. We pick 2 again. We push it one is finished. This level is done. Now we have another level which contains 2 values for now. So we popped this. We will still be left with a value that will tell one variable can tell me whether there is present a value or not. So 3 is present already, so 3 will be connected with, so 2 will connect with 3 if there is any value present. So 2 will be connected with 3 and 2's left and right will be pushed and 2 will be popped. So there is a connection between 2 and 3 now. So 3 will be popped. 3 will have nothing because at this level 2 was there. Level are not same. Their levels are not same. We can even keep track of levels together. So 3's left and right will be pushed. 5 and 7 will be pushed and 3 will be popped. Now 4 will be popped. 5 is there, its level is same, so we'll connect connect 4 with 5. 4's next will be connected with 5 and its left and right will be popped, and 5's. So okay, so this can be easily done with DQ. Maybe we could use DQ where we'll keep 2 things. Pair tree node, sorry, it's a node, and the next value which we'll keep is integer, which will tell me the level. So first is the node and the second is the level that we are talking about. So dq dot push back root. Root with level 0. Now I'll run while dq not dq dot empty. So I'll pick the element from front and I'll push it in back. So I'll pick the element from front. So the element that node dq dot front car first. This will be node and level will be dq dot second. Now if and dq dot pop front, I'll pop the front part. Now if dq, if not dq dot empty, if dq is not empty, and dq dot front dot second is equals to level. If the level is same, we'll do node of next will be dq dot front car first. Now I have popped this node, its left and right will be pushed in back. So if node left is present, then dq dot push back node left with level +1. If node right is present, then dq dot push back node right level +1. Do I need to return member access within null pointer? Oh, okay. If not root, return let's see if we submit this. Nice, great. So we can use dq for this. dq can easily solve this. So it's obviously a level order traversal. We are using a BFS approach only, but in BFS approach we can use Q, we can use DQ also. So there in here we are using DQ for solving this question. If you still have any doubt, let me know. I'll explain this in a better way, because I know what I am doing, but it might be possible that you are getting confused. So do let me know. I'll explain it in a better way. Okay. Okay. Uh, can we solve this? Can we try and solve this also? Let's try. Let's see what it is saying. You have an undirected connected graph of n nodes labeled from 0 to n minus 1. We are given an array graph where graph I is the list of all the nodes connected with the node I by the edge. Return the length of the shortest path that visits every node. You may start and stop at any node. You may revisit node multiple times, and you may reuse edges. Shortest path that visits every node. Okay. So it's already given in a graph form. From 0, 1, 2, 3. 3 nodes are connected. From 1, only one node, that is 0, connected. From 2 also 0 connected. From 3 also 0 connected. So it's already given a graph. So it's 0, 1, 4, 2, 3. 0, 1, 4, 2, 3. Or 0, 1, 2, 4. We'll have to 1, 2, 3, 4, 5. But 1, 2, 3, 4 is the shortest one from 0 to every other node. Okay, what we can do in this case, if we can think of no bro, I'm not giving biryani to anyone. Saurav, can you check, is my mic now better? Is my audio better now? uh, 0 is connected with 1. Yep, we can hear the cooler pump clearly now. Thank you. From 0 I can go to 1. Okay, so from 0 I can go to 1. From 1 I can either go to 2, I can go to 4. In 1 step, in 2 step I can go here and here. From 2 I can go to 4, and from 4 I can go to 2 in 3 step. Yes, we need noise cancellation or filter. I'll try and add filter next time. So from 4 we can go to 2. From 2 we can go to 4. From 4 we cannot go to anywhere, but we can go to 1. We can even go back to 2, but that will not be counted in my answer. And from 2 I can go to 3. This is the new node that we are visiting for the first time. In this path. N is only 12. So I can use a priority queue over here to solve this question. What we can do is from 0 we have a 0. We can from 0 we can go to 1. Correct. That's the only path that we can go with a value of 1. So from 0 we can go to 1 with a value of 1. From 1 I can go to 2 and I can go to 4. From 1 I remove 1. I can from here I can get to 2 with a value of 2. I can go to 4 with a value of 2. We can go to 2 with a value of 2. We can go to 4 with a value of 2. Means 2 nodes have been visited till now. or from 1 I can even go to 0 again. So from 1 I can even go to 0 again, but with a value of 2. Now from 2 I can go to 1. From 2 I can go to 1 with a value of 3. I can go to 4 with a value of 3. I can go to 3 with a value of 3. But till now, how many nodes are visited? That also I need to keep in track. This is just a count. You need to keep track of values also, whether we are reaching that value or not. So for that I can keep 3 things. The first is path, the second is node, and the third we can collect a set with some value. Which will keep track of node for this path. If this set contains, why are you smiling? It's talking to Barbie. She did some awesome job. We'll tell you on call. Bro, why are you watching my face, bro? Solve the question, na? Let's keep a priority queue which will contain a pair of integer. The second will also contain a pair of integer. And a set of integer. Me no coding. Bro, I do still remember that you told me that when you will go home, you won't be having your PC for 1 month. So you'll be doing coding in that month. I don't even see any progress in you. What's the progress, bro? Can you tell me? I did. How many questions did you solve? Yeah. Can you just give me some idea? You were also planning to do some coding and all the stuff regularly. I was thinking of that you will do that, but you're not even streaming Valorant regular basis. What I can do, bro? This. You're distracted. Okay. Even I have NVIDIA, but I'm not distracted. See, I'm doing. You can do it too. You can dedicate one day for this. Path, node, and unordered set total nodes. So now what we can do is I don't want 2K Ultra. 1080p is more than enough. Hey bro, don't distract me, huh? If you want, you can talk some coding stuffs, but not gaming stuff after this stream. So pq dot push, we have 0. The node is also 0 and set will contain nothing, empty. Will this work? Okay, we'll see you build 5090. That's in future. You can't talk our future today. Let's see what happens in future. What should I place? Just keep an empty unordered set. Unordered set of integer empty set and keep this empty set. Let's see. But first let RTX 4090 come. Let him come. No, still I can't keep unordered set in a pair. To make an unordered set of pairs, you can either create a custom hash function or you can make a no. Keep how to keep an unordered set inside a pair. Parent unordered set of integer. Expected some kind of iterator. How we can do that? Let's ask this from chat GPT. What is this? Full. What what reply are you giving, bro? Make pair. Bro, cheating? What cheating, bro? I'm not cheating. I'm just checking if it is possible or not. I don't think it is even possible. The thing that is doing. Let's see if. No, it's not possible. It's not possible. Can't do this. I'll have to think some other way. Think in some other way. I'll have to think it. We'll see you in 1 hour. Hello, compy. Play Swift, bro. Swift play. Go and do kid stuff. Hey, let me think. Let me think. I'll see you, Rena. priority queue. Zero index will contain the number of times. Oneth index will contain the total number of the current node, and the rest okay. So p2 dot push jet pq dot push 0 times 0 node and nothing else. We have did we visit any node? Yes, we did visit 0, right? So we have 0 while not pq dot empty. The priority queue is not empty. What we can do is we can directly push in our priority queue. We'll pick the first value. Times will be pq dot top and pq dot top now from here where all are possible ways where we can go. What all possible ways where we can go is we can go to 1. So if I'm at 1 currently, think, so we can go to 2, we can go to 4, we can go to 0, correct? I'm just thinking of keeping the 0 1 as same. From 2 will have node. I have to every time I have to check whether this node is present or not. If not present, then I'll push that node into this and I'll move forward. Crop comma index till last vector C. Okay, there is a slice. Google One membership, I don't know, maybe. Into another. So this is my original vector. This is my sliced vector. So original vector dot begin plus 2 original vector dot end. Okay. Total node is equals to total node. I don't have to do anything. Original vector is original is equals to tq dot top. I can even pq do tq dot pop. Original dot begin plus 2. Cool. So if 1 2 3 jet bro, jet, always a jet. You take Sage. Total nodes dot size is equals to n. Return times I is lesser than graph of nope, I got call. Time up. Okay. But I'm thinking of completing 8 hours. after 8 hours I still have half an hour left approx. After that I'll stop streaming. Graph node dot size. So now what I can do? Tea break. I'll call you after half an hour, Saurabh, don't worry. I'll give you a nice tea break. Both. Tea break and snacks. Graph of node of I. This is my new node. If new node is equals to total, if it is present in total node, present is equals to true. Threatening me live. Yes. I'll see you in half an hour, don't worry. Hello. No pal world. From 1 I can go to 2. So 2 will contain all the value and 2 as well. I'm getting confused with this vector. I shouldn't have used this vector before only. Because of this vector I'm getting lots of confusion. Should I use this total node? New list is first. total nodes. If it is not present, then now pq dot push times +1 new node and it will throw error. This will throw error. I need to combine both. Can you push? Wonderful. Huh. Saying it's coming out to be 5 from 0. I can Oh, I do not have to start from 0. Set. Yeah. If I would have started from 0, 1, 2, 3, 4 and 5. From 0 it is... From 0... I got confused with the question. If I would have started from 0, if it would have said from 0, start from 0, then visit all the other node, then this would have worked. So can we do something? Now I'm not very much sure that what will be the time complexity if I create a separate function for this. For I is equals to 0, I is lesser than size plus I. Now if I'll have to do solve, which will return me something. Result is equals to minimum of result comma solve of this. This will return something. This will have start node. This will have my start node, my graph, whole graph. So instead of putting 0, start node, this will also contain my start node. Solve will go with start node as I, and this has graph. Okay, so this time it is giving me true, but what will happen if I increase the test cases? Like from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. अरे जाओ अच्छे से. हाँ पक्का. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can have maximum of 12 nodes. So 1, 2, 3. आदमी नहीं. हाँ हुए तो 0, 1, 2, 3. नहीं तुम बताओ. 5 मिनट इधर चलते हैं. 0 1 2 3 4 5 6 7 8 9 10 11. Okay. Sure. Okay. Expected rows of graph to have 0 size. What is this, bro? Let's try and submit this. I think it will give me TLE. Knew that. Okay, no problem. I'll have to see this. I will look into this, and in the next stream I'll explain all the answers, approach on how to approach this, because I was not expecting. I was thinking of starting from 0. So if I would have started from 0, then I could have gone through all the nodes, then the time complexity wouldn't have mattered. But now we have to start from each node and we need to check. So in this case we need to apply some dynamic programming, or we need to store the answers somewhere. So for that I need to think how we can do that. Okay, no worries. I think we'll stop here, and in the next stream I'll discuss the approach for this also, using DFS and BFS both, and then we'll try to solve some more pattern based question. Today we solved till 7 tree BFS. So next time we'll start from 8 to 14, because there are in total 14 patterns, and we completed half of them. So next time we'll complete the rest of them, and that'll be very good for us. So hope you liked the video. If you liked it, please do like, share and subscribe, and thank you for watching. Thank you very much. See ya. Bye.